We are going to solve question number 6 of exercise 7.2. The question reads like this. Triangle ABC is an isosceles triangle in which AB is equal to AC. So in the given figure, triangle ABC, this portion is an isosceles triangle whose two sides are equal. AB is equal to AC. That's why it's mentioned here. Side BA is produced to D such that AD is equal to AB. So side BA is produced further to D such that now AB is equal to AD. We have to prove that angle BCD is a right angle. That means we just have to prove that this angle is 90 degree. Now let's try to solve it. Before we ever go into, let's understand the given facts here. First of all, it says triangle ABC is a isosceles triangle. Since triangle ABC is an isosceles triangle, since triangle ABC is an isosceles triangle, AB is equal to AC. AB is equal to AC is already given in the question. That means two sides of this triangle, this isosceles triangle, are equal. We know the property of isosceles triangle. If two sides of an isosceles triangle are equal, their opposite angles are also equal. That means the opposite angle of this side is C. That means angle ACB and angle ABC are equal. So according to the property of isosceles triangles, angles opposite to equal sides are equal. Therefore, angle ABC is equal to angle ACB. ACB. So let's now keep it as a, okay, we need not to mention it as an equation now further. Now let's look into here. The question further says side B is produced to D such that AD is equal to AB. So question is, what is given? AD is equal to AB. That's what given. Now AD is equal to AB. Now in the front we can see AB again is equal to what? AC. So let's compare. Let's put it as a 1 and 2. Now let's compare 1 and 2. When we compare that, AB is equal to AC. So let's replace the value of AB instead. Replace the value AB with the AC. So AD is equal to, instead of AB, I am going to write AC because here AB is equal to AC. So let me put it as 3. Now what we have understood is AD is equal to AC. That means AD is equal to AC. Now looking at this picture, if again there is a triangle here, DAC or CAD. This is another triangle formed whose two sides are now proven to be equal. So we have now proved that AD is equal to AC. AD and AC, two sides of this triangle DAC, are now equal. Now if two sides of a triangle are equal, their opposite angles are equal. So according to the above stated property of triangles, property of a triangle in triangle DAC, triangle DAC, two sides which are the AD and BC, are equal. Therefore, their opposite angles are also equal. That means, that is, we can say now, since these two sides are equal, their opposite side, the opposite angle of side AD is this. This angle is now equal to this angle. The opposite side of side AC is D. So angle ADC and angle ACD are equal. Angle ACD is equal to angle ACD is equal to angle ADC. So we have now found out two steps. Now what we have to do is that we just have to now add the corresponding parts. Now let us try to add the corresponding parts of these two triangles. So before we add, let's try understand the corresponding parts here. Now when we look at these two triangles, side AC is common to these two triangles. So it is shared by both of these two triangles, ABC and ADC. Now since this is the common side, its corresponding part is this one, its corresponding part is this one. So let's add this corresponding sides parts. First of all, let's add this corresponding parts. ABC, its corresponding part is ADC plus ADC is equal to, the next corresponding part is ACB, angle ACB, its another corresponding part is ACD, angle ACD. Let's try to look at this equation in comparison with the figure here. Now let me just take your attention to this side, angle ACB plus angle ACD. Now look at here, when we add angle ACB plus ACD, we get a larger angle ABCD. So here itself we can understand BCD, angle BCD is equal to BCA or ACB, angle ACB plus angle ACD. So the addition of these two angles will give us a larger angle, that is BCD. So instead of ACB plus ACD, I am going to replace it with ABC plus ADC. Instead this, I am going to write angle BCD. Now the next thing that we are going to do is that we are going to add BCD to both the sides of this equation we have got. So let's name it as equation 4. So add angle BCD to both LHS and RHS. So to come to our answer, we are going to add angle BCD to both the sides of this equation. So let me take this left side of this equation, that is angle. So I'll just take ABC, angle ABC plus ADC, angle ADC. Then as it has already been written here, I'm going to add BCD here, angle BCD I have added to the left hand side of the equation. Now what is there in the right hand side? Angle BCD. So as it has been written, I'm going to add a BCD to the RHS. So angle BCD. Now let's see that here angle ABC plus angle ADC plus angle BCD is equal to, here we can see that BCD plus BCD, that means it's a 2 angle BCD. So now let's put it in the reverse order, that is this way. 2 BCD is equal to angle ABC plus angle ADC plus angle BCD. Now let's look at these three angles. Angle ABC, angle ABC, ADC, ADC. So this portion of angle is covered. Now from here to here it's covered. Now ADC, ADC, then BCD. Where is that? BCD. So it covers a complete angle. We know, we have already studied in the previous chapters, the sum of angles of a triangle is 180 degree. We know that the sum of, since the sum of all three angles of a triangle is 180 degree. So the sum of these three angles would be what? 180. So we can replace the sum of these three as 180. So 2 BCD, to angle BCD is equal to, the sum of these three angles is 180 degree. So 180 degree. So let's take this to down. Angle BCD is equal to 180 divided by 2. So angle BCD is equal to 90 degree. 90 degree means what? It is a right angle. So hence we have proved that angle BCD is a right angle. That's why we have got the answer 90 degree.